Welcome to the Private Wireless podcast series from Nokia, bringing you the insights that really matter around enterprise digital transformation and wireless solutions. The series covers technology comparisons, deployment best practices, total cost of ownership assessments, analyst reviews and reports to help you make the decisions you need for your business. So keep listening. Nokia's MX Boost is a patented innovation that combines multiple radio technologies to extract their maximum value while avoiding increasing complexity. Today, Will Townsend, Principal Analyst for Networking and Security at More Insights and Strategy, is joined by Tristan Barra-de-la-Guerre, Head of Private Wireless Marketing in Nokia, to discuss its potential.
I want to welcome our viewers and listeners to another Private Wireless podcast with Nokia. I'm Will Townsend, and I lead the networking and security practices for More Insights and Strategy. Joining me again is Tristan. Welcome, sir.
Thank you, Will. Happy to be here.
Great. Well, let's jump right into it. So I know in previous podcasts, as we focused on private wireless, we talked about the benefits of cellular, LTE advanced as well as 5G versus Wi-Fi, and primarily in supporting operational technology use cases and environments. I mean, I personally believe that Wi-Fi and cellular are better together, but I'd love to get your view on where you see the role of Wi-Fi within Industry 4.0 and just driving broad digital transformation.
Well, what we observe today first is that private wireless networks based on 4.0G LTE or 5G are gaining more and more traction in asset-intensive industries as a way to power Industry 4.0 use cases. And as a matter of fact, Nokia is today providing private wireless solutions to more than 450 customers. However, the majority of those enterprises are what we call brownfield campuses, which means they have legacy wireless connectivity in place, such as Wi-Fi, that they cannot simply switch off and that they will use for years to come. There are also customers which are testing Wi-Fi technologies first, then decide to add industrial 4.0G LTE and 5G devices, particularly when there is an issue of a specific use case. Issues which generally comes from Wi-Fi limitations in mobility, coverage, and interference management. For all these reasons, industrial plants often end up with a mix of connectivity technologies, such as, for example, Wi-Fi and 4.0G LTE.
You know, from my perspective, it's been sort of even more of a mishmash than just Wi-Fi and cellular. There are a lot of other modalities as well that are legacy, that are sort of throwbacks. But a couple of thoughts I have. One, when you look at the improvements in Wi-Fi 6, there's tremendous improvements in latency and throughput, as well as additional device support. And when you think about an industrial environment with sensors and that sort of thing, I think that comes into play. And then I think you touched on it really well, Tristan. And from my point of view, really it's going to be the use case. And so, you know, you have to figure out the balance that's required for the workload, for distance, like you mentioned, propagation and latency. And that's ultimately, in my mind, going to drive the decision on whether you choose cellular or Wi-Fi or both. But those are great insights. So it sounds like you sort of agree with me that they're better together. But private wireless within the enterprise, it's sort of a black box for a lot of organizations that have been just accustomed to managing Wi-Fi. And there's also a lot of complexity with private. When you look at cloudification, when you look at the momentum that's building behind Open RAN, and also just the whole notion of managing licensed versus unlicensed spectrum. So I'm wondering, from your perspective, how can industries extract the maximum value from all of these various radio technologies and mitigate that complexity?
Yes, and actually the answer is a new innovation called Nokia MX Boost for private wireless. It is a Nokia Bell Labs patented technology, which makes it easy to combine, for example, 4.0G LTE or 5G private wireless connectivity with Wi-Fi. The result is an aggregated multipath connectivity that supports OT use cases And typical benefits for the industries are an optimized throughput in difficult radio conditions and an improvement in what we call determinism for very critical applications. So with such solution, industries have a way to better leverage their multiple radio technologies and get the best of both.
No, that sounds fantastic. I mean, I'm familiar with MX Boost, and I believe it has the potential to reduce the complexity of managing these multiple wireless modalities. And, most importantly, I sort of talked about how enterprises are just now getting their feet wet with cellular, and that can help sort of demystify the whole notion of managing cellular within the enterprise. But specifically for our viewers and listeners, Tristan, how does MX Boost actually work?
MX Boost is an IP-based solution, which means that it is extremely simple to implement and has a limited impact on the network solutions it uses. It is deployed as a banding and routing application on our MX Industrial Edge, which is the name of the Nokia OT Edge platform, and on our multi-modem industrial devices. It works without any changes on wireless access points, making it completely radio technology, spectrum, and vendor agnostic. Enterprises can run MX Boost in one of two modes to meet the needs of different applications. The aggregation mode, which will boost data rates in difficult radio conditions by splitting and recombining traffic from multiple radio channels. So it includes performance probes on both links to measure in real time the quality of the channels to optimize reliability. And the replication mode, which duplicates the same data, the same packets on all radio links and automatically selects the best one. This mode aims at boosting reliability, latency, and mobility.
I like the fact that it leverages edge technology, and I've often spoken about the power of edge, and it's no surprise when you look at mobile operators around the world, they are edge enabling their networks through a lot of hyperscalers like Amazon Web Services and Azure. And I've written about this on Forbes. From my perspective, edge enablement can supercharge these use cases, and it can really benefit both Wi-Fi and advanced LTE and 4G. So those are some great insights, Tristan. Often when I speak with customers, I get a question, and the question is, I hear about this private 5G. Should I just throw Wi-Fi out the window? And so I spend a little bit of time and I say, well, let's understand your use case and your application. But from your perspective, what would the typical implementation of an MX Boost look like? And would there be specific situations that it would be appropriate?
One typical usage of MX Boost is to aggregate Wi-Fi 6 and 4.9G LTE for business critical OT applications that require high data rates, capacity, and quality in specific hotspots. For example, it takes up to 10 cameras to enable remote control of a port crane. The combination of Wi-Fi and 4.9G LTE bandwidth allows for the exclusive use of, for example, 4K cameras. In case of a degradation of the quality of the Wi-Fi connectivity, MX Boost automatically switches back to 4.9G LTE and to full HD camera. 4K camera is one example. We can think of other data-hungry applications, such as high-quality sensor-based applications, for example, for molten metal impurity detection, and also augmented reality maintenance applications.
From my perspective, getting back to that whole question, whether you do Wi-Fi or you do cellular 5G, you mentioned, 4K cameras, mixed reality experiences. I think these are use cases where the power of 5G will really shine, right? Getting to that sub 5 millisecond latency, anyone that's, had a negative experience while streaming content and you get the buffer and the spool can understand, the challenge there. And that's really required also that ultra low latency for tactile operation of robotics and that sort of thing within industrial environments. But you mentioned, I think, a very, very important point that MX Boost is sort of vendor agnostic. And I think this is important because the reality in most enterprise environments is that they're multi-vendor. And that's done from a cost consideration perspective and just a continuity of supply, right? As we see what's happened coming out of the pandemic with supply chain shortages and that sort of thing, I think it's mission critical. But can you talk a little bit more about how MX Boost can work within these multi-vendor environments?
Yeah, so what I said before, MX Boost technology is based on IP layer, which gives a huge flexibility for the integration of existing connectivity technologies, including in multi-vendor environments, which is important to support most of the legacy Wi-Fi. So MX Boost opens up also new possibilities, for instance, using Wi-Fi for non-critical OT applications. In the past, we've said that Wi-Fi is only suitable for IT applications because of its inherent limitations in coverage, mobility, latency, and reliability. But with the MX Boost, enterprises can meet the needs of these applications with Wi-Fi by using MX Boost in replication mode to get the best performance and reliability from several Wi-Fi bands at the same time. For example, Wi-Fi 6 and Wi-Fi 6E, and to support applications such as operation management tools, storage systems, and worker information systems.
You know, I'd also add too that, you know, another way that you can get sort of better propagation and performance is just densify the access points within a deployment. And if you look at, you have to do the cost trade-off, right? So from a Wi-Fi perspective, it's a lower bill of material cost. So that platform is going to be less expensive than cellular. And it's also leveraging unlicensed spectrum. With respect to a cellular solution, that bill of material is higher. I mean, that the semiconductors in that solution are higher. It's leveraging licensed spectrum. So there's also a cost trade-off as well. So it might make sense for a customer to consider MX Boost and then densifying their APs. But with that said, Tristan, are there any other considerations where MX Boost could be ideally suited?
Yes, actually, in some countries, industries have access to multiple spectrum bands. So MX Boost can be used also to combine, for instance, various radio technology types like 4G, 5G, multiple spectrum bands such as centimeter wave, millimeter wave, or disparate 4G bands. Typical benefit includes, for example, increasing the determinism for mission-critical OT applications in challenging environments. Enterprises can use MX Boost to replicate data connectivity on two 409G LTE bands to improve reliability. This mode is particularly interesting in highly loaded areas with challenging radio conditions, such as in ports, metal factories, and mines. And our testing shows that by replicating the data on two 409G LTE links, we can meet the demands of critical machine control applications that use Profinet profiles that require reliable latency below 30 milliseconds. This approach provides a way to anticipate actually the future use of 5G SA Release 16 or Release 17 industrial features to provide level of determinism or performance that couldn't be normally reached with a single 409G LTE band. Applications in this extremely critical category include cloud programmable logical controller, so cloud PLCs, and emergency systems.
Great insights there, Tristan. So I think as we sort of wrap up our conversation, we've talked about, you know, both Wi-Fi, we've talked about cellular, we've talked about how MX Boost can really simplify the complexity and managing that within the enterprise. But I'd like to spend a little time on Wi-Fi because I know Nokia has a very strong portfolio here. And so it'd be great if you could share with our viewers and listeners what the company is doing to strengthen the portfolio and offer customers more choices. Because at the end of the day, from my perspective, more choices, more flexibility is just, that's the best path for a customer.
Yeah, so what I said at the beginning, there is little doubt that 409G LTE and 5G private wireless networks will become the predominant connectivity choice for manufacturers and other asset-intensive industries that want to reap the benefits of digitalization and Industry 4.0. But a recent ABI survey showed that some of these enterprises still see Wi-Fi, and especially the new Wi-Fi 6, 6E technology, as a viable connectivity option for some non-critical operations. For such a reason, we have decided in Nokia to integrate Wi-Fi as part of our Nokia DAC, so the Digital Automation Cloud, with our own Nokia Wi-Fi indoor and outdoor access points, and with Wi-Fi controller and AAA deployed as applications on our Edge platform. By deploying Nokia DAC Wi-Fi, enterprises can then make a seamless transition to private wireless as their needs evolve, leveraging the most deployed private wireless solution in the market, also based on Nokia DAC. And for the enterprises that have deployed the Nokia industrial-grade private wireless solution first, Nokia DAC Wi-Fi can be added to provide a complementary capacity layer at specific locations for non-business critical applications. All is integrated in Nokia MX Industrial Edge to ensure that all connected asset data is processed on the premises. And to help enterprises optimize the network total cost of ownership, the solution is offered using a scalable and disruptive as-a-service subscription model. The solution also simplifies network operations, which is important in that enterprise space, with a unified management interface for all wireless connectivity technologies.
Well, I'm really impressed because obviously Nokia is a world leader with respect to cellular infrastructure. You're bringing that into the enterprise. You have a world-class Wi-Fi portfolio from my perspective, up there with the likes of Qualcomm, MediaTek, you name it, and then MX Boost that comes together to allow enterprises to manage both more easily. And that's the critical part, is that you've got to figure out how to make this easy for enterprises to not only deploy, but to manage after day zero. So Tristan, it's been another really insightful conversation. I want to thank you for your time, and I want to thank our listeners and viewers for tuning in again.
Our thanks to Will Townsend, Senior Analyst at More Insights and Strategy, and Tristan Barra-de-la-Guerre, Head of Private Wireless Marketing in Nokia, for joining us today. It's exciting to hear how MX Boost optimizes network reliability and performance for the most demanding industry use cases. Thanks for listening to the Private Wireless podcast series from Nokia. Don't forget to subscribe and be the first to hear new episodes. If you're looking for more insights around all things private 4.9G LTE and 5G, contact the Private Wireless team at Nokia. To find us online, just search for Nokia Private Wireless and click Talk to an Expert to get in touch.